Hey everyone, and welcome to this explainer. If you follow tech even a little bit, you're probably already drowning in AI news, daily tool drops, and honestly, a relentless amount of hype. Well, today, we aren't here to just give you a basic introduction. We're here to cut through the noise. We are going to completely strip away the magic and break down the architecture, the limits, and the real-world stakes of AI into a sharp, undeniable masterclass.
Okay, let's take a really quick look at our roadmap for today. First, demystifying AI. Second, going inside the machine learning engine. Third, the generative AI boom. Fourth, capabilities and limits. And finally, number 5, debating our AI future.
Before we get into the heavy architectures, we absolutely need to lock in our baseline and bust some of the biggest myths right away. Look, we all know AI isn't a conscious, sentient, magical being, right? It's literally just heavy mathematics, statistics, and computation. It doesn't have feelings, it just simulates intelligent responses. But crucially, it is never neutral. Because it's trained on human data, it's essentially a digital mirror that reflects and sometimes even amplifies our own historical biases. Oh, and just a quick reminder, a robot is just the physical hardware. AI is the invisible software intelligence actually running the show.
All right, let's jump right into Section 1, Demystifying AI, its origins and definitions.
So as you probably already know, the AI we use today is what we call narrow AI. It is incredibly specialized. Like an algorithm that optimizes global shipping routes is brilliant at its job, but it absolutely cannot write a poem for you. Think of it exactly like a hammer. It's the perfect tool if you need to drive a nail, but completely, utterly useless if you're looking at a screw. This is a super critical boundary to keep in mind because it separates the tools we use right now from that sci-fi dream of artificial general intelligence, which would adapt across any task. We are just simply not there yet.
And you know, this stuff didn't just appear out of thin air last year. It has been a decades-long grind of complex mathematical breakthroughs, mixed with some really brutal funding winters, where the hype completely outpaced the reality. The journey stretches all the way back to Alan Turing's theoretical questions in 1950, to narrow AI having a huge moment when Deep Blue beat Garry Kasparov in chess in 1997. But the real tectonic shift? That happened in 2012, the deep learning boom, finally fueled by massive data sets and cheap GPU computing power, directly set the stage for the generative explosion we're navigating today.
Moving on to Section 2, let's pop the hood and look inside the machine learning engine.
So, how do these systems actually learn? Well, they operate through a couple of distinct paradigms. With supervised learning, you've basically got a strict teacher. The AI trains on millions of explicitly labeled data points, like this is spam or this is not spam, until it learns the rule perfectly. Unsupervised learning, on the other hand, is like being thrown right into the deep end. The system is given entirely raw, unlabeled data and told to just find the hidden architecture on its own. It's like a corporate algorithm spontaneously discovering a new, highly profitable group of shoppers based on behaviors that human analysts completely missed.
But training is definitely not perfect, and understanding the system's flaws is absolutely crucial. The biggest trap is something called overfitting. This happens when a model memorizes its training data way too perfectly, capturing all the useless background noise, but then utterly fails when it encounters fresh, real-world data. It's exactly like that one student who memorizes a practice exam but completely bombs the actual test because the questions change just a tiny bit. In the real world, an overfitted high-frequency trading bot might look flawless in a historical simulation and then lose millions of dollars the second a live market shifts.
To actually fix those kinds of errors, AI relies on an optimization algorithm called gradient descent. Imagine the AI is blindfolded, standing on the side of a really steep, uneven valley. Its only goal is to reach the absolute lowest point at the bottom, which represents a zero error rate. So it takes iterative, mathematical steps, kind of feeling the slope with its foot, tweaking its parameters until it safely settles at the bottom. That is the literal mechanism of how the internal knobs of machine learning are fine-tuned.
All right, Section 3. This is the flashy stuff, the generative AI boom.
We are way past just classifying data now. We are deep in the era of AI that predicts and generates entirely new things. The tool you reach for depends entirely on the underlying architecture. You've got transformer models like ChatGPT and Claude, which are purpose-built for sophisticated text, coding, and logical reasoning. Then you have diffusion models like Midjourney, rendering photorealistic, incredibly high-quality images out of basically static noise. And then there are platforms like Suno, generating complete radio-quality music tracks with full vocals from just a single sentence, which is just wild.
But since you already know the basics, you know that amateur prompts yield amateur results.
To extract real enterprise-level value from these tools, you need a solid framework, like this 5-step prompt engineering method. First, assign a role. Tell it to act as a senior data analyst. Second, provide context to ground the response. Third, issue a precise command. Fourth, strictly dictate the format, like asking for a specific table structure. And crucially, step 5, use chain of thought. Simply forcing the model to literally think step by step exposes its logic and drastically reduces reasoning errors. It is a total game changer.
Okay, reality check time. Section 4, Capabilities and Limits.
For all its insane processing power, AI has some absolutely terrifying blind spots. Let's be real, it possesses zero common sense. It might understand thermodynamic physics perfectly, but it doesn't intuitively know you shouldn't put a metal fork in a microwave. It hallucinates, making up entirely fake information with absolute, unwavering confidence. This is exactly how we've seen real lawyers accidentally submit fake AI-generated case law to federal judges. It's also a black box, meaning its reasoning is completely opaque to us, and it is entirely at the mercy of its training data. Garbage in, garbage out, right?
And that brings us to the core operating principle of our era. Look at where the strengths actually lie here. AI is unmatched at scale, speed, processing vast data patterns, and working 24/7. But humans, we hold an absolute monopoly on common sense, empathy, moral judgment, and true adaptability. So the winning formula isn't replacement, it's augmentation. It is exactly like a pilot using an advanced autopilot system. The tech is incredibly powerful for sure, but the human absolutely must remain in the seat to provide the contextual oversight that machines fundamentally lack.
Which leads us nicely into our final section, Section 5, Debating our AI Future.
The rapid deployment of this technology is forcing society into a series of massive structural collisions right now. If audio and video can be perfectly faked using generative models, how do we as a society agree on a baseline of truth? And what about copyright? If massive models are trained on the distinct styles of living creators, it raises a huge debate over whether those people should be compensated when the machine generates commercial work that directly undercuts their livelihoods.
Take education, for example. The ground is completely shifting under our feet. We are being forced to define the exact line between a tool that helps a person brainstorm or structure their ideas and a tool that actively does the thinking for them. Is it cheating? Banning these tools outright basically ensures people graduate entirely unprepared for the modern workforce. But unguided integration risks outsourcing our critical thinking completely. And honestly, outside the classroom, the stakes are literally life and death. When we start handing over agency to AI in high-stakes environments, think medical diagnostics, autonomous driving, or judicial risk assessments, we hit a profound dilemma. We are trading massive efficiency for that terrifying black box problem. When the machine inevitably gets it wrong, the total lack of explainability and accountability has devastating human consequences.
So, I want to leave you with a challenge as we wrap up this explainer. The future clearly belongs to those who use AI to augment their capabilities, not those who just wait to be replaced by it. So look at your own workflow today and ask yourself, what uniquely human skill, whether it's empathy, complex strategic judgment, or creative intent, are you actively strengthening to ensure you remain irreplaceable? Thanks so much for joining me today, and I'll catch you next time.